Hello and welcome to the Extended Greg YouTube channel. I'm Greg, and today we're going to be building a digital video clock on a Raspberry Pi running Alpine Linux. It's a great way to add a little bit of spice to your environment and really match your vibe. So before we get into it, be sure to smash that like button and subscribe if you haven't subscribed, because we're about to get extended. So let's go ahead and get right into it. So what we have here is we actually have the output of the clock itself, and it's just a regular Raspberry Pi. I'll show you that really quick. So it is just a regular, I'm using a Pi 3B Plus in this particular case with a PoE hat, but it really doesn't matter which version of Pi you use. Obviously the newer ones are going to be a bit better. I wouldn't suggest using anything less than the Pi 3, just because it has enough horsepower to be able to do what you want to do, play the video out very smoothly, and be able to create a good experience. It is doing a real-time composite, where at the end of the day it is actually putting some transparency over a looping video background. And that's the key thing here, is that instead of it being like the previous clock that we made, which just had a regular console type output, where we just kind of made it so it would show the numbers in a larger format, using some block text and pretty much a lookup table. This is actually generating it using FFMPEG to be able to overlay the arbitrary text in real time. So what we're actually using to do this, I've written a nice little repository and posted it on GitHub. And pretty much this has all of the things that you need, including the instructions on how to do it. So we're going to go ahead and actually do that. We're going to do the build from the ground up, and the link is in the description if you need it for the GitHub itself. But it kind of assumes that you have a done setup Alpine already, so you already have internet access to be able to do the download, and you already have NTP set up, because it does rely upon that in order to get its time synchronization. So let's actually go ahead and get that set up first. So first thing I'm going to do, I'm just going to clear out the actual Pi, and then we'll start setting it up. So I have a shell here. I do believe I need to restart this or duplicate it. Let me dupe it. Oh, good, it kept the text size. So I'm just going to log in here really quick, and we'll go ahead and delete the config. So I'm going to just mount the actual partition as read-write. Oh, look who it is. Gonna say hello? It's Nala. Gonna say hello? Boop, boop, boop. Boop, 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 boop. She's excited. She's excited for dynamic clocks. She likes video. Right? So we're going to do media MMC BLK0P1, and then I'm just going to delete the APK OVL file, which in this case is called video clock. Excuse me, I'm not going to do that yet until I mount it. Then we'll do RM/media MMC BLK0P1 video clock. Alright, so now we have nothing saved, right? Nothing up my sleeves. So we're just going to reboot this. And let's watch it in real time as it reboots. And we're just going to boot it to the console, and this is why I have other cables connected to it. And this is just the latest version of Alpine, which is 3.22. So it is 3.22.0. So at this point, it is the latest version. Everything runs pretty darn well on it, and I'm very happy with the improvements they made recently. So let's go ahead and do setup Alpine. I'm going to choose my key map. I'm going to choose a host name. In this case, it's going to be video clock. And notice these errors that keep coming up where it says clock skew detected. That's something that just started happening with 22. And I'm not sure how to get rid of it. Maybe they'll fix it in a future version, but it just detects that there's clock skew, so it kind of messes with the interface until you get the actual clock synced, and then that clock skew message goes away. So don't worry about that. We're just going to go to the first thing where it says which one do you want to initialize, question mark or done, etc. So we're going to choose a default for Ethernet 0 for hardwired in this particular case, since I'm using PoE, and we're going to do DHCP, and then we'll do done. Technically, it will work with wireless LAN as well if you wanted it to, but I don't in this case. And we're not going to make any manual changes. I'm going to set a nice secure password. Wonderful. I'll put in my time zone, and the time zone does matter in this particular case because it will display in local time. So whatever your time zone is set to for the system is the time zone that will show up on the clock. So important that you set this correctly. All right, so now no proxy in my case. We're going to use Crony just for no other reason. All of these are good options. They will all synchronize the system clock, and that's really all that matters. So I'm just going to choose Crony just because I happen to like it. And now those warnings will go away. So once it gets to the next command, we won't see it anymore. We're going to choose a mirror. I'm going to choose C for community repositories, and then I'll choose option 1, which is the default CDN. I'm not going to set up a user in this case, although you could, but for this script, it doesn't require it, and you'd actually have to modify the setup in order to do it. I am going to enable SSH though, because we'll use that for the other configuration, so I can do copy and paste. So for this, since we only made a root login, I am going to type yes. I'm not going to enter an SSH key, although you should for production, but just because we're just demoing this here, it'll go a little bit faster. We're not going to do a disk install, and we're going to use the memory card as our actual place where we're going to store everything. Now, the nice thing about this, so we're done with our actual setup itself on the console. Now we can go over to SSH. So I'll just commit this. Perfect. So now we can go back over to the other machine, and I can restart this. Accept the new cert, log in. Perfect. So I'm going to be jumping back and forth. Let's see if we can get both on the screen here really quick. And I'm trying to make the text big, so obviously, it's going to be a little smushed. But the whole idea, and just covering like some of the main features, is it uses motion video background. So anything that's compatible with FFmpeg will work. It pretty much will do any kind of clock, any kind of display that you want. So like as an example, right, I have this Raspberry Pi 7-inch display. This happens to be a WaveShare display, but it's nice because you could just mount the Pi directly on the back of it, and then you have a nice little 7-inch display, right? I'll even do the peel for you. Oh, that's nice. There's another peel, but I'm not going to peel that one yet. But short form, I like IPS displays just because they do have a wide viewing angle, and especially when you're looking at a clock, you might want to actually see it from many angles at once. So it makes a big difference. So it's also settable with the 12-hour or 24-hour time format. The default is 12, but we'll go over what those defaults are at the bottom. And then it's optimized for Raspberry Pi. So what I actually have it doing is I have it pre-scaling the actual background video to be native format for whatever the size, whatever the resolution of your monitor is. And that means that it won't have to do on-the-fly scaling of video, which Raspberry Pi doesn't really do very well. And that keeps it from lagging and allows it to pretty much play at full frame rate. So I think that's very good. It also automatically centers the text regardless of what your resolution is. It has quite a few options in terms of configurability. You can set your own fonts, you can set your own font sizes, colors, things like that to match whatever your needs are. And it also keeps since it is technically still just using the regular frame buffer, it's not using X11 or anything else like that on top of it, which means it's a very lightweight installation. it does keep the cursor out of the way and then restarts it once you exit. So technically you can actually, there's a console under there that you could use. But just jumping right into it, we're going to go ahead and just follow the instructions here. So we're going to go ahead and copy APK update and add screen packages screen FFMPEG, and then a font package, which is font Deja Vu, which is a TTF font, because it does need TTF fonts in order to work properly, which are true type fonts. So we'll just copy this in here and let it run, and then run the last command. And it's just going to install a number of packages. We see not too much space is being taken up. And that's important because when it actually transcodes the video for the background, it's going to store it in RAM. So obviously if you use a Raspberry Pi with a lot of RAM, in Alpine Linux, half of that RAM is used as your default drive. So like if I do df-h, and let's make this full screen and then rerun that. Yeah, that kind of worked. No, it didn't. All right, so here on the slash, right, and this is a tempfs, so this is actually running in RAM. We see we have 300 megs available. And, you know, we'll need that for the temporary video file. Depending on the resolution that we use, obviously it's going to potentially use more. So, going down to the next command, we're actually going to download the zip file of this repository. So I copied the command, I'm going to right click, and we're going to download it just to the root directory. It's not very big at all. We ls into here, we see main.zip is the actual zip file itself. And what we're going to do next is unzip main.zip. And if we ls after that, we see that it created a folder. So next we're going to cd into that folder. And if we ls into there, we see there's only a handful of files. It has the license, the readme, which is this instruction that we're reading here now, as well as video clock, videoclock.conf, and videoclock.sh. And they all have the same name, but they're all slightly different or different enough. So if you just follow the next few steps, it will tell you exactly where to put those, so that way it starts automatically when you boot up the Raspberry Pi. So first thing that we're going to do is we're going to copy the videoclock.sh file to the bin folder. And then we're going to give it executable permissions, that way we can run it. So we just did that. And I wonder if actually it would be easier to do top and bottom. You want to try it with me? Let's see. Will it work? I don't know. I don't think that has that as a layout option, because who would ever want that? I mean, you know. Alright. Well, next we're going to create a folder for our configuration. So we'll do make dir-p /etc/video clock, and that's a folder. So we'll go ahead and run that. That created that folder. And then we're going to copy our comp file into that folder. Next, we're going to place our init script. And the init script is actually what's going to run it as a service on boot. So that way you don't have to be logged in order for it to start up. It's going to start up automatically, but the Pi is technically still going to be secure, because even if you started typing, you'd just be typing into the login screen. So if you didn't know the username and password, you wouldn't be able to log into it anyway. So we'll go ahead and run these three commands, which is to copy the init file. We're going to make that init file executable, and then we're going to add it to RC update in order to start using. It's going to start by default with the other programs in the default run level. And we see it's been added successfully. Next, because we actually have this running from RAM and we don't have it as a disk install, we need to add it to LBU. If you did do this as a disk install, you don't need to do this step. It'll automatically be saved. But in our case, we definitely need to add it. So we're going to run these commands, and then we'll save it out as well, just to make sure that we're preserving everything. Now, the next thing we want to do is we want to use a program like FileZilla to actually upload our background file. So let me open that here really quick. And this is going to be kind of small, and I apologize. I can't make it bigger. But I'll just narrate what's going on here. So I'm going to log in to the IP address using the password and user that we created during setup Alpine through SSH. And in this case, I'm just going to keep it in the root directory, because I'm just going to store the video file there. And that is actually the default location where I have it set in the config. So if we don't change anything in the videoclock.conf file in the etc folder, we will be able to just use that directly. We won't have to change anything. So I got a couple of options here. It will take 4K, but it will take forever and a day in order to actually transcode. So I did make a low-res one here that we can use to be able to kind of use it in the interim. So it'll just be a little bit faster in order to be able to do everything. Now, the big thing, I probably should add this to the instructions, but we need to make sure that we change this name to match the /root/background.mp4, so that way it knows where to find it. I mean, we could just change the actual etc config file, and it does mention that there, so anywhere you set it in the config file and any file name you can use, but I always find it easier just to make it a simple name. So we'll do cd back to the main directory, which is root, right? And if we ls in here, we do see that mp4 file right here. So let's go ahead and do move to rename it, and we'll do the file name, and I'm just going to change it to background.mp4. Right, and we see it right here now. So we've now renamed that file. Now, in order to make sure that that file also is preserved through reboots, we're going to do lbu add /root/background.mp4. And then we can do lbu commit-d. Now, technically that's it. One other step that we have in here, which is step 10, is to just actually open up the config file itself in a text editor and make any adjustments that we feel we need. So I'll show you really quick. This is actually what it looks like. And the options you have are to choose your video source for the background. You can choose your font file. By default, we're using the Deja Vu Sans Bold TTF from package font Deja Vu, which we installed earlier. The text color is going to be white. The background color is going to be black with 50% transparency. And we're going to use frame buffer 0, with the small font size being 30, the large font size being 90. And then we're going to use the 12-hour format. But we can come back and play with these settings as we want to. So we'll quit out of that, and now we can do /etc/initd video clock start. All right, and now it's started. So if we actually go back over to the direct output of the Pi itself, we're going to be seeing something while it's loading. So what we're going to see is it will do that loading prompt and show you the actual frames as it's transcoding. And then once it's done, the clock will appear and it will play at normal speed, which will be more fluid. In this particular case, it may look a little jerky on screen just because I have weird frame rate conversions going on here. So the actual output of the Pi is doing 50 Hertz, where I'm streaming at 30 frames a second. So it does look cleaner on a local monitor that I have here, but you could try it for yourself, and honestly, it will do 60 frames a second. It doesn't really care. It just matches whatever your actual monitor display is and what your native video frame rate is. But we see that it's operating fluidly. It's taking the current time, which is accurate for the time that I'm streaming right now. And then pretty much that's it. You can put whatever background you want to have there, and you can change the colors. You can change things like within the actual running script itself. So if you didn't like a background, you could go to FFmpeg, look at the reference, and you could put, you know, a border instead, or a shadow, or anything else that is available in the draw text. And we can go through that script really quick just to kind of show you exactly what makes this tick. Pardon the pun. I'm sorry already. Right? So, taking a look at this, right, and I told you these are the default settings right here, listed in the README as well. And then it shows you video clock start, video clock stop, and just kind of gives you a little note on the RAM usage and things which I mentioned earlier. But looking at the video clock sh file, it kind of it's all written in shell, right? So it's not compiled in any way. It's something that you can plainly read and modify easily. And it shows you the default configuration here. So technically you don't need the config file if you don't want to. If you just want to edit this directly, that's totally fine. And then it's going to create the temporary video file, so it sets the path to include what the current PID number is. So if you start multiple outputs for some reason, so multiple frame buffers, things like that, technically you could do that. It also defines where the cursor blink will actually be set, and it's just trust me, if you set it to 1, it turns it on. If it set it to 0, it turns it off. Some cleanup, so after it's done, it'll actually delete the temporary files, things like that. But getting down into the actual nitty-gritty of it, it's going to check and see what your settings are, everything else like that, get it pre-configured. It's going to determine your screen width and your screen height automatically based on what the actual frame buffer size is. It's then going to start by pre-scaling your video. So it'll run an FFmpeg instance. It will split that out, and see if I could scroll over. It will split it out and it'll actually push it to the frame buffer, the same as when it's pushing it to the file. And it just makes it a lower res, or potentially higher res, H.264 file. Once that's done, then it goes into its final loop, and it will pretty much loop forever, but hopefully if it never crashes, it only has to run it once. And it will forever loop over that background video file and play that on the background, and then draw 2 lines of text over it, which are the date and the time, using the settings that we set, and then output that to the frame buffer as well. If it does crash, it will sleep for a second, and then it will loop back into the time display without actually having to retranscode everything, assuming that's not the reason it crashed. So it's a very short script. You know, there's you could modify this to your liking. If you don't want to use box, you know, I tried to lay it out as best as possible to make it so it's easily extensible. But that kind of covers that. So going back over to the output itself, I'm going to reboot this for you and we can watch it in real time together. Oh, and I just realized I have it on the other screen, so I can't even do it. Let's see. Okay, so I'm going to do reboot. Ready? And then we'll switch back over really quick. 1, 2, 3. Reboot. It goes down. Switch back over to the output of the clock. Perfect. Okay, good. I was afraid it wasn't going to detect and then it was going to just be sitting on a black screen. So, all right, we see it loading right now. Right, we didn't make any changes after we did all of the configs, everything else like that. We saved everything where we needed to. Fingers crossed, because we followed the instructions. And now it's going to get its IP address, it's going to sync its clock, we see Crony D. Now the error messages for the clock skew go away, and it's going to finish, and now it's loading. Right, so it's loading, it's doing that real-time transcode. This happens to be very similar to the actual resolution that we're outputting, but point being is that it's doing that transcode and then immediately enters the clock and starts ticking away. And if it does lose network connectivity, anything else like that, it will be using the local internal time, so it will just keep ticking away. It may drift a little bit, and then when the network comes back, it will automatically resynchronize to NTP, which will get it back in business to make sure that it stays synchronized, and also make any time adjustments that it needs to for daylight savings, for example. So, but that's pretty much what I got for today. So, thanks for watching this stream today. If you like it, be sure to hit that like button and leave a comment down below. And if you know anybody who would like this kind of content, be sure to share it with them. I would appreciate it, and I hope they would appreciate it too. And if you have any ideas for content, be sure to, post them down in the comments. I do read all the comments, and I try to respond to all of them, or at least acknowledge all of them with a nice like, or even a favorite. So, thanks for watching this stream, and if don't forget to check out the link in the description for the GitHub. But until next time, take care, and thanks for watching.